Hello and welcome into the content video, the first video for lesson number 4. And in this lesson, we're going to be looking at solving linear equations, solving linear inequalities, and also solving absolute value inequalities. Solving linear equations, I'm not going to spend a whole lot of time on that. Maybe just give you a refresher, but more than anything, I just want to give you the caution, give you the warning, be careful with your arithmetic. So a lot of times when I'm grading exams, when I'm taking off points, it's because the arithmetic is wrong. You are adding, 2 to both sides and you do 3 plus 2 is 6. All of a sudden you're doing multiplication instead of addition or something like that. And so if we have, let me share the document camera. That might be a little bit important here, huh? All right, there we go. So with a linear equation, so what makes it a linear equation is that the variable has an exponent of 1. And the variable, it could be anything, x, y, a, b, z, w, whatever. The variable can be anything that we want. Could be a Greek symbol, alpha, beta, something like that. But the key is that the exponent on that variable is just 1. So we might have something that looks like ax plus b equals some value c. And so all we're doing with a linear equation is moving the pieces around, doing the opposite of what is there in order to get the x by itself. So the first thing we would have to do is, because this is plus b, is we're going to minus b from both sides. So we get ax left on the left side, and then c minus b on the right. And then, of course, to get x by itself, divide both sides by a. So you get x is equal to c minus b over a. And again, those will all be some integers, things like that. So that's linear equation. Like I said, I'm not going to spend a whole lot of time on that. If you don't know these, then you probably better come to office hours because we are going to have a long semester ahead of us then. Okay, so linear inequalities. So this is when we have, so an inequality is our less than symbol, less than or equal, greater than, or greater than or equal symbols. And so we solve these like we would a linear equation. However, and this is the big thing, if we, and this is key here, if we multiply or divide, so not add or subtract, that doesn't, or subtract a number, that's not it. It's just we're multiplying or dividing by a negative number, then we must reverse the inequality. So very straightforward example here for you. What does this mean? let's say I have negative 2x is greater than 6. Well, if this was just 2x equals 6, I just divide by, sorry, negative 2x equals 6, I just divide by negative 2 and that's it. But because I'm dividing by a negative 2 to get x by itself, I have to reverse the inequality. So instead of greater than 6, it's now less than equal, sorry, less than, and then of course we do our math. So the negatives 2 cancel out, we get x, and divide this side by negative 2 gives us negative 3. And so, of course, if we had to draw this on a number line or write it in interval notation, that means what? It's negative 3, open circle, going to negative infinity. So it'd be negative infinity to negative 3. It's not included, so it's just less than, not less than or equal. So it gets a parenthesis. So that's sort of the different ways that we would attack that one. So that's linear inequality when we have just two sides of the inequality here. But we can also have another format of linear inequality, but it looks a little bit different. And so this is where we have two inequality symbols. And so now instead of just like negative 2x is greater than 6, we might have something like, let's say, some value a is less than, let's call it n for number in front of x, plus c is less than some value b. So we sort of have this three-part inequality, but we're still going to kind of solve it like a linear equation. We're trying to get this x by itself. So I have to do what? I have to subtract c here. But now because I have two inequalities, I have two pieces, I have to subtract c everywhere. So on the left side, I get a minus c. These guys cancel out, so I just have that number times x, the coefficient. And here I have b minus c. But again, I want to get the n by itself. So I divide everything by n, and the rule still applies. If this is a negative number, I have to switch the both of these inequality symbols. So the n's cancel out, so we get what? We get x's between a minus c over n and b minus c over n. So it's kind of like we're solving two linear inequalities at once when we have those three pieces. All right, and so that's our linear inequalities. That's our inequalities with two symbols. So the last thing, and this is a shorter video, and that's okay because the last lesson, of course, was a little bit longer. But we have our absolute value inequalities. And we have two cases, either less than or equal to, or greater than or equal, if we have that equal sign there. And so depending what type, whoops, sorry, let me move that up. Sorry about that. So we have two types. We have less than or equal to, or greater than or equal to. And so depending what type we have to solve this in two different ways. So for the first one, when I have less than or equal. So I might have x is less than some value c, or x is less than or equal to some value c. So to solve this, to get rid of the absolute value symbol, I'm going to rewrite both of these like we had our two-part inequality, like we just got done doing, right? Going to write it like that. So x is less than c, but also, and here's the tricky part, greater than negative c. And this one's the same, negative c, positive c. It's just it's less than or equal on both of those. So when we have less than or equal, this creates our sort of two-part inequality. Or, find a different color pen here, maybe green. The second case is when I have x is greater than c, or sorry, absolute value of x is greater than or equal to c. So let's think about what absolute value means. That means the distance from zero on the number line, right? So this one up here means that if I was to draw this, well, here's zero. It means I'm out here at C and I'm down here at negative C, and it's all this stuff in between. That's what this absolute value is saying. It's between both sides of this C. But now it's saying I got to stay away from zero. So if I was to draw this on a number line, it's what? It's C, but it's got to be bigger than that, or negative C and less than that. And so that's the equation that's going to get generated for both two of these now. We have x is less than negative c, or what do we know about or? That's our union. X is greater than 3, greater than positive c. Not 3c. I don't know why I said 3. Or if it's greater than or equal, same type of inequalities. It's just now less than or equal to negative c, or greater than or equal to positive c. And in the second video, the content video, the sample problem video, we'll look at some examples of these guys. So don't stress out if it's not making a lot of sense. Once we see some numbers put into place, hopefully it'll make a little more sense to you. But that's it. That's all I have for content for lesson 4. Pretty straightforward. Hopefully some of this, some concepts might be new to you. But again, once you work a few of these problems, it's like, oh, okay, I know how to do these now. So we'll see you guys in video 2.